Thanks for coming along. How's the morning been so far? I haven't seen anything. How's it been? Good? Awesome. That's silence. I'm going to assume that means it was amazing. So welcome. Today I'm going to be talking about cleaning the sewage out of your DevOps process. I'll talk about what that means in a sec, but some of you have probably noticed I talk a bit funny. I thought I'd start with telling you who I am. So my name's Damian Brady. I actually work for Microsoft now. As of literally this time last week. I've been home for 2 days since this time last week, so I haven't really got everything set up. So I'm really hoping that this laptop's not going to lock me out at some point, because I don't have a badge yet. I am a cloud developer advocate at Microsoft and part of Donovan Brown's self-styled League of Extraordinary Cloud DevOps Advocates, which he seems determined to see if that can catch on, so we'll see how that goes. So I'm that guy who looks a little bit like a hologram because that photo wasn't very good. We're going to redo this photo at some point, but that's me. Prior to Microsoft, and most of you would know, I work at Octopus Deploy, if you know me. I used to work at Octopus Deploy. So prior to that, I started about 15 years ago with software development, and I started in government, so I know how the government system kind of works, at least in Australia. I moved on, worked in a couple of different finance companies, building .NET solutions for internet banking and things like that, and then some loans software and things like that. I moved from there into consulting, so I ended up visiting a lot of places and finding out how they did their DevOps process, although it wasn't called that then, it was just the process. And then I moved on to Octopus Deploy, and so as well as being in a product company, I also saw how people did their deployments and things like that. So I've kind of got this varied history in a lot of different environments where people have done things very, very differently, especially in the case of government versus Octopus Deploy, where we could deploy a new version to production in about an hour with a couple of lines of text in Slack. So yeah, it's changed a bit. I originally come from Australia, around not too far away from here. This was a little bit earlier than this time last year, so that's winter in Australia, by the way. It was about 30-something degrees, I think, so not very nice. So I come from around this part of the world. There's a lot of other speakers from about the same place, actually. Troy Hunt lives about 45 minutes south of where I was. But Christmas Eve last year, my wife and I actually moved to Toronto, which was a bit of a shock. We kind of exchanged Vegemite and drop bears for maple syrup and real bears. I think that's a trade up, I guess. The big difference, though, was this is Australia in summer, which is around Christmas, and this is Canada around Christmas, right? This was the first time that my wife had ever seen snow. I know you have snow here, but we had never seen it before, really. So that was a bit of a shock. We are heading back home at the end of the year, so I'm kind of looking forward to getting back to the beach as well. Yeah, so that'll be exciting when we get back. I'm going to let that run twice. Anyway, so today's talk is really all about the scenario where there's a lot of organizations who have jumped on this DevOps bandwagon, but have found it's a lot harder than what they think, and it doesn't really work for them is usually what we hear. Now, that doesn't necessarily mean that DevOps itself is a bad idea. It's usually that the implementation of it is not working so well. And we saw the same thing with Agile when that became a thing. A lot of people trying out Scrum and finding, Scrum doesn't work for us. It's not that Scrum's broken, it's just that the implementation didn't work so well. So now it's DevOps, right? And people are saying, well, we tried to do DevOps, but it didn't really work. So today's talk is all about the most common things I see in people's DevOps pipelines that makes them think that DevOps is just not working and is not for them, and how to fix them, how to identify them, and how to move forward and start getting it to work. So it would not be a DevOps talk if I didn't have a definition of DevOps. Thankfully, my new boss, Donovan Brown, has the definition of DevOps that Microsoft uses, which is the union of people, process, and products to enable continuous delivery of value to our end users. I won't dwell on that too much. I think people by now kind of know what DevOps is. The general idea is you're delivering like real value to people who are using it, and that's the idea behind it. In terms of an actual pipeline, this is kind of what I'm talking about here. There's a number of phases, and it actually does move in a circle. You need this feedback loop rather than just requirements all the way through to production, and then that's done. There is a feedback loop that needs to happen. And the idea is basically to move through this pipeline as quickly and as safely as possible. I'll talk about that in a sec, but as developers, we don't have a huge amount of control over the top two, number 1 and number 4 there. Planning is often out of our hands, and monitoring and learning, yes, we can add some monitoring, we can collect this data and things like that. Learning what we need to do next in a lot of organizations is kind of not our job. We get told what stuff to write and so on. So I'm going to concentrate a lot more on the bottom part of this loop, but I just wanted to mention a couple of things at the top, because this is one of the big problems that people have with DevOps if they don't close this loop. The idea of monitoring what happens in production and then learning from that is hugely beneficial from a DevOps point of view, and something that a lot of companies don't do. It's the way you learn about what bugs there are, what new features you should be working on, and any rework that needs to happen. If you've ever developed a feature, added it to a product, and then found that people aren't really using it, or you're not getting any queries about it and you're wondering why, it turns out it's actually really hard to discover or something like that. By monitoring what's happening in production, you can be alerted to that much earlier than if you're waiting for your customers to tell you about stuff. And remember, the work that you should be doing day to day fits in really nicely with this definition of DevOps. It's about continuous delivery of value, right? If you're working on brand new features that nobody really wants, and I know there's a lot of software out there that seems to do that, they work on features that nobody asked for, rather than fixing the problems they do have, then you're not really delivering value, are you? So the idea here is to actually look at what's happening in production, what people want, what's going wrong, and working on that, because that's going to provide the most value. So here's the number one thing that I see, at least in this sphere, of something that's going to get in the way of a good DevOps process. And it really just comes down to this, that there is no feedback loop. The developers will write the task, they'll move stuff from the left-hand column of the board to the right-hand column, eventually it gets to production, but that's the last the dev will ever see of that task, right? They don't know whether it succeeded from the point of view of a user because there's no monitoring. Nobody really knows whether somebody's using this new feature or not. And so this is a problem. To do this, to fix this problem is obvious. You just create a feedback loop, right? You add exception handling that notifies you if exceptions have started climbing in production. You look at feature usage. Are people using these features that we've got in there? Even performance monitoring, stuff like if I deploy this new feature, have we suddenly pegged the CPU and something's gone wrong? There's not really an excuse anymore for finding out about this stuff from your customers or from your users. It's something that you should be able to notice as much as possible before you get to production, but even if it is in production, you should notice this stuff before somebody comes screaming at you. And I have been in those organizations where I got a page at 2 a.m. and somebody's yelling at me over the phone rather than letting me go and fix the problem. But that stuff happens. There's not really any excuse. If you're a .NET dev, Application Insights, for example, is pretty much free. Once you start using it in a lot bigger volume, then sure, they'll make you pay for it. But sorry, we will make you pay for it. I got to get used to that. I personally will make you pay for it if you start using it. And then you can even tee it up to Power BI and stuff like that to give your managers nice charts about who's using stuff and what the performance is and things like that. Outside of the Microsoft stuff as well, there's one of my favorite tools is Raygun, built by a team out of New Zealand as well, which means I think because it's out of New Zealand, I think that Australia gets to claim it. If it's successful. That's how it works. If you're in Nick's session earlier, Serilog and Seek as well are awesome ways of managing the exceptions and the stuff that happens in your application. It's structured logging that means that you can find the information you want really, really easily. So all of these tools are available to you. There's not really any excuse for just finding out something's gone wrong because somebody gives you a call. Like I said, I don't want to focus too much on that, so let's just jump back to our DevOps pipeline and we'll start talking about the stuff that we can control a little bit more as developers. One of the things that is important about this is that it is a feedback loop, and so the kind of goal of DevOps is to move as fast as we can, right? To get this cycle time fast but safe. There's kind of two guiding principles. There is move fast and make changes safely. So in other words, we want to make it really easy to push good changes out to production, really easy and fast to get good changes in production. And anything that's bad, anything that causes problems or causes bugs, we want this pipeline to stop it from getting to production. So move fast, but make changes safely and not let anything bad get to production. In practice, from a pipeline point of view, this really kind of equates to automation and testing. So automate everything you can so that you don't have to sit there and click buttons and drag files around and queue builds yourself and things like that. But also make sure that your pipeline is really robust so the good stuff can get to production really easily and the bad stuff gets stopped before it becomes a problem. So let's look at this bottom part here, the develop, test, build, and release kind of part, which is what, as developers, this is the bit that we have a lot more control over. So if we can think of this part of the pipeline as a bit more of a pipeline from one side to the other. Right? Develop, test, build, and release. Now, this is obviously kind of a grey area as well. You want to do testing at different points. You want to release to test environments, do some more testing, and so on. I'm actually going to swap the test and build around because development, obviously, you're going to run tests locally as well. We don't really care about that from a pipeline point of view. We want to build our software and then we want to test it and make sure it works. And if everything's okay, then we can release it to production. So just to make it a little bit easier to walk through this process, I just swapped those around. So let's start at the start, obviously, which is the development part. How teams work and the writing the code part of it and the problems that I see in organizations that feel like DevOps isn't working for them. What can you do about that from a development point of view? The number one guiding principle here is that devs should be writing code most of the time, right? In an ideal scenario, they should only write code. You write code, you commit it. If there's a problem with it, you find out immediately and you just fix the problem. So all you're doing is writing code. You're not involved in the actual deployment process of dragging files around. You're not pulling down everyone's changes and building to create a release candidate. You're not, running through manual testing processes and things like that. You're hired to write code, so that's what you should be doing. So the biggest problem that I see here in terms of something that goes wrong with pipelines is that you have a pipeline that is waiting on other people to do stuff. So what I mean by that is that imagine you have made a change to your code and it works, it's beautiful, but you still have to wait for this other team who has broken the build and they just need to fix that up, right? I can't release this change that I've just made until somebody else fixes their problem. You're getting in each other's way. And there are ways to get out of each other's way, right? This being in each other's way and having to wait for another team to do their job before your code can go out means that cycle time just slows down. In fact, it just stops until that happens. Getting out of each other's way, there's a couple of ways that you can do this, and this is really where we come up with branching strategies. So, having feature branches or team branches and things like that is kind of a way of getting out of each other's way. If you're doing work and it's not finished yet, it shouldn't prevent anybody else from pushing their changes through. Feature flags kind of goes a little bit better than this, especially if you're using it in the context of dark launches of code. Provided your code compiles and it doesn't break any tests, if it's behind a feature flag that is turned off, that can go all the way to production. That code won't run in production, which means that half-finished code that's behind a feature flag that's turned off can still be deployed to get a different feature out or to get a different change out. And I can keep working on it until it's ready to go. It's harder to do in practice safely, but it's definitely a really powerful thing. If you can wrap all your changes in feature flags and just leave them off until you're ready to actually deploy, turn them on briefly, make sure everything works, and then just remove the old code. That's a really powerful way of making sure that you're staying out of the other developer's way. Branching strategies, though, they can come with their own problems, particularly if you get to a scenario where you have what's called continuous isolation. So as opposed to continuous integration, continuous isolation basically means that the code you're working on gets further and further away from the master branch or from the main branch of your code. If you're working on a branch that hasn't had any merges from master for a period of weeks, that merge is going to suck, right? Getting your code working with everybody else's code is the hardest part of any branching strategy. The merge is the worst part. So continuous isolation really describes when you have these long-running branches, and you really, really need to avoid that. As much as possible, trunk-based development is a great way of avoiding these merge pains, or at least working out what the problem is as early as possible. So everybody working on the same branch is a great idea if you can do it. And you'd be surprised how many people do this. I'll show you in a sec, but Microsoft, the team that actually writes Visual Studio Team Services, basically does trunk-based development, and there's a lot of developers working on that. But if you can't do pure like trunk-based development, if it's a little bit hard, there's too many teams working on too many different things, then at least make your feature branches short-lived. The definition of short is going to completely depend on your organization, how much work happens, how quickly. But if you have, one or two developers who commit maybe once a day, twice a day, maybe you can go for weeks without the merge going to be an issue. If you have hundreds of developers committing constantly, then you really want to be close to master. You don't want to let that stagnate, get isolated for a very long period of time. So short-lived feature branches. Another technique I've actually seen that gets around this quite well is the idea of a what-if continuous integration build. In other words, if we're working on a branch, that's fine, but have a continuous integration build that means that every time I commit code to that branch, there's a build that merges it with master and does a compilation and identifies the problems that are going to occur when we actually do that merge later. For one thing, if it doesn't merge automatically, you know that you're going to have to do some manual stuff when you merge that later on. And it's a good idea to know that ahead of time. Or if code does merge perfectly, but now this really unexpected test breaks, at least you know before you have to go through that process of merging. Particularly if you're in a scenario where you merge your code just before you start doing a deployment, which happens in a lot of organizations. So this kind of what-if build is not a bad idea either. Now, I mentioned that Microsoft does pretty much trunk-based development. This is a screenshot of the actual Visual Studio Team Services code base. So they're using Git. The thing I want you to notice, though, is how clean, relatively clean, that path is. There's not all of these feature branches coming in from all over the place. And this is like 5 hours worth of commits, roughly 5 hours worth of commits. There's also about 25 distinct people committing in this as well. So it's not like you have 3 or 4 people who are working very closely together. There's teams working on very different stuff, on very different code, and the clashing is not really happening because everything's more or less trunk-based development. Now, they still do pull requests, they still do topic branches, they call them, but they get merged into master really, really quickly. So the merge conflicts with a huge team are kind of gone. So this is it is possible in a large organization with a large number of developers. So I just want to summarize this development stage of our pipeline. There's a few different things that can go wrong that we see. Number one, waiting on other people. And so branching strategies and maybe even using feature flags and things like that is a good way of getting around those problems. But with branching strategies, you've got to be careful that you're not doing continuous isolation. In other words, you're merging really consistently. The term continuous integration really means integrating your stuff with everybody else's stuff. So having a CI build that just builds on each branch individually and doesn't merge, that's not continuous integration, that's continuous isolation. There's actually a really good website that talks about the practicalities of trunk-based development and what that actually means in organizations as well. That's worth having a look at. So that's the development stage. Let's move on and talk about the next part that I want to talk about, which is the build part. So the number one guiding principle, I think, for doing DevOps properly from a build point of view is that builds should be automatic. Right? You shouldn't have a person in your organization who pulls down the code, does a build manually, and then sends it out. It's kind of similar to the previous point in that developers should be writing code. They shouldn't be trying to work out how the build's going wrong or build's working and things like that. The build also gives you an opportunity to do like a first pass filter. So if your code doesn't compile, having a continuous build, for example, means that you know that immediately. It's not going to be 3 weeks later when you've forgotten what the code looks like that you work out that you've introduced a bug or you've introduced something that prevents it from compiling on a production server or on a build server with everybody else's code when it gets merged. The idea of finding out these problems as early as possible is what people who talk about DevOps talk about shift left. So this is the idea that, you remember our pipeline where we had develop, build, test, release. You want problems to be identified as far left in that pipeline as possible. Everybody knows that fixing a bug while it's on your machine, like while you're writing the bug, fixing it then is so much cheaper than fixing it when it's in production. So shift left refers to the idea of trying to notice and fix these issues as far left in that pipeline as you possibly can. So this is what we talk about when we talk about shift left. A build server gives you a great opportunity to do that, or the build phase gives you a great opportunity to do that, because you can immediately tell if your code's not going to compile, and you want to know that straight away, not a week later. So the biggest problem with DevOps that people who find this issue have is the idea where they build locally ready for a deployment. So the biggest problem with this is that it's not automatic. So you want to know when the build is going to break, like immediately, right? But you also don't want to have to rely on somebody pulling down all of everybody's changes and compiling and making sure that they all work together. You really want that to happen straight away. If you're relying on a particular person doing a build for a deployment, then you're going to have to wait until that person is ready to do it. They're working on their own stuff, right? Just before you do a deployment, they're like, yeah, let's grab everybody's thing, we'll do a compile, and oh, there's weird stuff that's gone wrong. And this often happens with these deployments that happen on a Saturday when everybody comes into the office, right? You need to work out how this stuff fits together first. You want to know this straight away. So, like, number one, the easiest thing you can do is set up continuous integration with a build server. So continuous integration is basically every commit, there's a compilation. It gets merged with everybody else's changes, and there's a compile. You end up with an artifact at the end of it that is your compiled application. It means that you can commit and be told that you've broken the build within a minute or two, often, depending on how long your build takes. If you're not doing this, if you don't have a build server that's doing this, this would be my number one suggestion to improve your process. Like, there's nothing easier to do than install a build server, and then you never really need to worry about whether your code compiles or merges with everybody else's again. It will tell you straight away, right when the code that you wrote is at the forefront of your mind, not a week later when you've forgotten it. The good thing about this as well is that, especially if you're a .NET developer, build servers are pretty much free. Like TeamCity, unless you use it at a particular volume, again, TeamCity is free. Visual Studio Team Services actually has a good build engine now. The old XAML one was atrocious, but the new one is really good. And it's free unless you have like huge volumes going through. And presumably by that point, you're making enough money, hopefully, that you can pay for it. So you can just start using this stuff. Anyway. So yes, build server, continuous integration. That'll at least get you moving fast and mean that your problems have been shifted left. The other problem that I see with this pipeline is builds that also do deployments. And this is a really common strategy that people do, where they have a development build or a test build, and then like a staging build, which will recompile, deploy to staging, and then a production build, which will recompile and deploy to production. Now this is dangerous because even though you may do these compilations in a short period of time, there is always the chance that something is going to be different between them. So when you deploy to your test server and you run through all your tests, and then you decide that that's all going to work, and you do a staging build, for example, you are now pushing different bits to staging, different files. They may technically be more or less the same because nothing's changed, but you can't be sure. The last thing you want to do is push some bits to production that have never been tested, and that's exactly what this kind of strategy does. Even no matter how confident you are, there's always the chance that something's going to be different. So as much as possible, you want to build your application once, build your binaries once, and deploy it many times. So deploy it to your test environment, deploy it to your staging environment, deploy it to production, and so on. Now, commonly people will say, yeah, it's not realistic, like stuff's not really going to go wrong. Like, it's a build on the same build server. We don't patch in between our releases and stuff like that. Imagine having a build that is like your test build. You deploy it to test, run through all of your unit tests, all of your integration tests. Everybody runs the thing. It looks like it's fine. So you do a new build ready to go to production, and these tests wouldn't pass anymore. Like there's bugs cropping up. Things that worked in staging just don't work in production. You only built these things like a very short period of time, like away from each other. You can't figure out what's going on. So this actually happened. With .NET 4.6, the initial release of 4.6 introduced bugs when you did a build with the optimize tag turned on. So this is what people were doing. They were doing doing a build for their test environment, like a debug build with optimization off, deploying it, running through all their tests, and then rebuilding for production with the optimize flag turned on, and methods were getting like the wrong arguments passed to them in the underlying code. So if everything had been built once and then deployed many, many times, you would have at least seen these problems in your test environments first, and you could have dealt with it then. So this was a bit of an issue. This is just an article from the Register, I think it's 2015. So this stuff can happen, right? Not to mention, if you patch your build server, then maybe the binaries are going to come out different when you compile again. So it is something to think about. Build once, deploy many times, which means that your configuration needs to be outside your build. You shouldn't need to recompile to deploy to a different environment, for example. The other idea is a bit more general, which is just make sure you're using the right tool for the job. Build servers are good at building. There's deployment tools that are really good at deployment. Octopus Deploy, for example, is still definitely my favorite deployment tool, right? It encourages you to do the right things. Things like building once and deploying many times. You don't have a new package to deploy to each environment. You deploy the same package to all your environments. So the tooling can help you do this sort of stuff. But you want to use the right tool for the right job. That's just a generally good idea anyway. And again, pretty much free until you get to a certain level of volume. Octopus certainly is. Release Manager, I think, is free-ish until a certain point, again. Same as the build tooling. So from the build point of view, there's a couple of things that I mentioned here. Things to avoid. Building locally. To do that, get a build server and continuously integrate your code, right? But also make sure you're avoiding continuous isolation there. So yes, builds that also deploy. Your build server should be building your artifacts and then use a different deployment tool to actually deploy those artifacts. That way you are testing the same bits as are going to go into production, and you're deploying them the same way, ideally, which I'm actually jumping ahead of myself. But it means that you know that this code is going to work because you've tested the exact same compiled assemblies, right? So that's really important. All right, so testing phase. So we've worked out the problems with our development process, getting in each other's way and slowing each other down. We've got our build engine, which means that we can find out whether we've introduced problems immediately. We're building once and making sure that those binaries are going all the way through to production, rather than having unexpected failures occur because we've rebuilt everything. So now we want to make this pipeline really, really secure and really robust, meaning that anything that we do that's bad is just not going to make it to production. So in the test phase, and this is going to seem really weird, but the test phase, the number one thing is that tests should do testing, right? This sounds ridiculous, but it actually occurs a lot, where people will write tests that don't actually do what they're supposed to do. In other words, tests don't fail when something goes wrong, right? And you actually see this a lot. I think the reason that we see this a lot is because code coverage became a big thing with testing. This might be controversial and a lot of people probably disagree with it, but I think code coverage is one of the worst things that we've done for a testing point of view. Because not only are you not worrying about whether this test is serving its purpose, which means it fails if something is changed and it breaks, all you're worrying about is have I exercised all of the code? Have I gone through it all? Which means that this test here, for example, it's a legitimate test. It will contribute to our code coverage, but it's not really testing anything. If you haven't noticed, that's the assert at the end of it, right? So we have code coverage, but if we introduce a bug in this, it's not going to break, right? Code coverage gives us the false sense of security that we've got tests over all of our code so we don't need to worry about it anymore. But if the test is not written well, then it's not actually serving a purpose, and it's making us feel safe when we're absolutely not safe. So, by the way, this is code from Ben Cull, the guy who's doing the beer for Thursday night. I made him change the assert. He's not actually doing this, just in case you ever use any of his products. He does have real tests in there that do real asserts. Anyway, this is obviously a contrived example, but it's very easy to see if you go looking in a lot of companies, people whose tests basically amount to create some mocks and then call a thing and make sure that the thing is calling the right functions in the mock. In other words, create mocks and then make sure the mocks are being called. That's not really going to fail very often in a real world scenario. It's not testing what you need it to do, or need it to test. One of the techniques which is really valuable in this is the idea of red-green refactor. Has everybody heard of red-green refactor? Yep, okay, most hands. The general idea is that you see a bug, and instead of just fixing that bug straight away, you write a test first. You make sure that test fails because there's a bug in it. Then you fix the bug and make sure the test succeeds. So it goes red, you fix the bug, and it goes green. And then you do any refactoring and changing things around, secure in the knowledge that if you break it again, the test is going to go red. You've seen it go red when it breaks. So often this is like red, green, refactor, red, 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 damn it, revert, and come back. But the idea is that you have the test in place so you know when something breaks that the test is going to alert you to that. So this is a really good strategy. Test-driven development is along the same kind of lines as well, where if you have a new requirement, you write the test first before you've written your code, and then your brain is just verifying that you wrote the code that you just thought you wrote. You write the test first to set those expectations. It will go red because you haven't written the code yet. And then you write your code to actually implement that function and make sure your test goes green. So same idea. You know that you have a test that's going to fail if something goes wrong. It's serving its purpose. The other thing which you see a lot with tests is people ignoring tests as well. So saying things like, oh, this test actually fails in staging because we don't have this backend database thing or something like that. Just ignoring that that's a problem. Or saying, yeah, the test fails, but that doesn't matter in production because it's slightly different, something like that. This is a really bad habit to get into. A lot of the time, people will comment out tests as well because they're like, oh, this is failing at the moment. It's just temporary while we're doing this stuff. I'll comment it out for the moment. Or even worse, you just comment out the assert because then you get the code coverage. But even the deployment process as well. So if something goes wrong during deployment, then you want to make sure that your pipeline can handle that and will let you know if there is a problem in the future. So imagine a scenario where, for example, you deploy to a staging environment, but it fails halfway through because there's not enough disk space. It's really common to say, well, production's got tons, I won't worry about that. Well, let's just clear up some disk space, run the deployment again. Oh, yeah, it worked, great. And now you deploy to production. It would be much better to apply those kind of red-green refactor techniques to your entire pipeline there. So rather than just saying, oh, that's fine, it's a different scenario in staging or something, you actually add something to your pipeline to check for that scenario, check that there's enough disk space, and only let the thing continue if there is. That way, one day, when production runs out of disk space, when you do the deployment, you can find that out before you actually do it. It's going to stop you from making a mistake in the future. The same kind of thing with integration tests, system tests, things like that. Don't ignore them. If something pops up and you say, oh, that's not a problem in production, don't worry about it. No, add to your pipeline to make sure that if it does become a problem in production, it's going to catch it before you get there. So don't ignore these tests. The other thing I see in the test scenario that breaks a good DevOps pipeline is the idea of extensive manual testing. Now, are there any testers here, by the way? No? One? Okay, I apologize in advance. Computers are better at running through scripts than people are, right? So if you have testers or a test team that needs to run through this gigantic spreadsheet of scenarios where the instructions are more or less, go to this page, click on this link, type in your name, press OK, and then go to the next page and it should have this text on it, that's a script, right? And if you tell a computer to do that script, it's going to do it the same way every single time. people aren't as good at that as computers are. So let the computers do those scripts. Now, the best testers that I know are the ones who are automating themselves out of this terrible part of their job. You know, the clicking around and just data entry style testing. If you can automate that process as a tester, you are extremely valuable. It means that you don't have to keep clicking around all the time, but that test is going to get run. It'll get run faster and it'll get run more consistently than a human could do. Now, I'm not saying that this kind of clicking around exploratory testing is not valuable. What I am saying is that do those, but they shouldn't block your deployment process or your DevOps process. This actually works really, really well in combination with feature flags, particularly from the dark launch kind of perspective. If you're writing some code, you wrap it in a feature flag that's off, you can continually deploy this to production. Maybe you don't really know what tests need to be run at that point. So your testing team can flick the flag on for themselves, do some exploratory testing, find the bugs, and then give it back to you before you flick the flag on for the general public, right? This is actually the way that the VSTS, the Visual Studio Team Services team, works as well. They do a lot of testing. They actually have 50,000 tests, I think, that run in 6 minutes. They do a lot of parallelism. It's insane. But they wrap everything in feature flags. They push it out all the way through to production through their all of their different environments. And then when it's in production, they're like, okay, we need to work out whether this actually works. Let's turn it on for a very small subset of people, like just our internal team. Do some exploratory work, do some exploratory testing. Oh, this thing's going wrong. Let's add that test to our pipeline. Make sure it won't go wrong again. Fix the bug, push it all the way through. Okay, we're good now. After that point, the automated test is going to pick up any kind of instance where that bug comes up again. So it gives you an opportunity to do this exploratory testing, work out what needs to be tested, what's going to go wrong, before you actually get it in the hands of everyone. So exploratory testing, great, but don't let it block your process, all right? Terrible scenario if you have developed all of this code, it's all ready to go, and then you have to wait a week for the test team to go through and test everything manually. In the meantime, all of your work is piling up. You're forgetting what you did. So when it does go to the test team and they say, there's a bug in this, you're like, I don't remember that code. And then you do a git blame and find out that it was you 2 weeks ago. Yeah, anyway. I may have done that once or twice before. Okay, so there are a few different points here in the test phase as well. So number one, which is the most important thing, is that tests don't fail when something goes wrong. You really need to make sure that your tests are serving the purpose they're supposed to serve, which is not code coverage. So red-green refactor, test-driven development is really useful for that. And apply the red-green refactor techniques to your whole deployment process, your whole DevOps process. If a bug gets through to production, that's not just a failure in your code, that's a failure in your pipeline. Your pipeline should have stopped that bug from getting to production. So add something to your pipeline to prevent that from happening again, and then you don't have to worry about it from that point forward. And then finally, any kind of extensive manual human-driven process that stops the deployment of your code is not going to help you from a DevOps perspective. It's going to make you feel like this isn't actually any faster than it was before, and now we're just waiting all this time. So this pipeline, the idea is to get from one end all the way to the other, not one end halfway through and then, then be held up by people. So I think I've said before that a pipeline with a human step in the middle isn't a pipeline anymore. It's two pipelines joined by a dumb human, right? So try and get the pipeline from end to end. That's really important. All right. So now we've got a pipeline that's testing effectively. We are now at the point where we want to deploy all the way through to production. So let's talk about that. This is kind of my wheelhouse, I think, the deployment stuff, at the moment at least. So number one thing for the release phase is that your deployments should be easy to do and very predictable. In other words, it shouldn't be your every 6 months everybody comes in on a weekend, spends 48 hours like hating each other, and then goes home at 3 a.m. on Monday morning because the deployment went horribly wrong and so on. They should be really, really easy to do. I'm ahead of time, so I'll tell you, back when I moved to Canada, the rest of the Octopus Deploy team is in Brisbane, Australia, where the circle was in the map. There's no time zone overlap between those, like no business hour time zone overlap, which means I didn't really get to talk to the team that often. What that ultimately meant was that I was working on peripheral stuff. I wasn't working on the main code base. I was working on integrations with VSTS and stuff like that. So I hadn't actually pulled the latest source code down for maybe 5 months. I woke up one morning and there had been a new deployment, a new version of Octopus Deploy that had gone out to production. And there was this really weird edge case where somebody was going from like 4 versions earlier to this current one, and it didn't work. So they upgraded Octopus and it wouldn't run anymore. And they've actually since fixed this problem, so you can't do that anymore. It'll tell you before it's too late. But it was enough of a problem for us to say, well, we can't let that one stand, so we took that download off so nobody else would download it. Keeping in mind, the rest of Australia, like the rest of the company is asleep, and I haven't touched the code for 5 months, and I needed to fix it. So I pulled down the code from GitHub, I worked out what the problem was, and I fixed the problem, and I committed the code and pushed it to GitHub. All of the continuous integration ran, all of our tests ran, everything looked okay, and I'm like, okay, let's do a release. So I went to Slack, which is our chat tool, and I typed in release Octopus Deploy 3.1.4 or something like that. And then I just waited for about 20 minutes, and then there's a new version in production, right? I hadn't touched this code for close to 6 months. I wasn't actually sure whether I'd fixed the problem properly. Like, it looked fine to me, all my local testing seemed okay, but I was confident enough in our pipeline to know that if I had made a mistake and something had gone badly, that wouldn't make it all the way through to production. At least not worse than what was already in production. So that pipeline was going to prevent any bad stuff from happening. But the deployment itself was so easy, I just typed in a line in Slack. And I knew it was going to work because this process is predictable. I know the deployment does the same thing every single time, and it's worked every version before now, so it's going to work now. So that was a deployment that was easy to do and really predictable. That gives you confidence. It means that you can deploy more and more often, and whenever you feel like deploying, whenever there's something to deploy, you can just do it because it's easy. The biggest problem with this, once again, is that there's a human in the process. So the deployments that happen where there's somebody who has to do 1 or 2 different tasks, that really, really slows down your cycle time, especially if you have sign-off processes and things like that. And I'm not saying that those are completely useless, just that they're not that useful, I guess. So you want to take the humans out of the deployment process as much as possible, right? Out of the whole pipeline, but deployment especially, which means automating everything, right? Automate all your deployments. And there are some pretty good deployment tools that do this work. Once again, Octopus Deploy. But if you're not in a .NET scenario, there's like SaltStack, I don't know, there's a bunch of other ones. There's no shortage of deployment tools, and they're built for that. They're built for deploying your application in an automatic way. But there are some things, like sign-off processes, that you can't automate. You really, in a lot of organizations, you need a manager to, if not add any value by signing something off, at least be the person who is the fall guy if something goes wrong, which is often what these sign-off processes are. The manager will insist that they have to sign this stuff off, but they have no idea what you've done. They'll basically say, did everything pass? Did all the tests pass? Does it look okay? You say, yes. And they're like, okay, we'll sign the thing, right? That is a process that does not need to happen, right? Now, actually putting this into effect is harder in a lot of organizations than just saying, hey, manager, your job is useless. That's probably not going to get you where you need to go. But at least you can optimize this process and make it less of an issue. At least speed things up for you. I mentioned that I worked in government as my first job out of university. There was an occasion then when a DBA got a SQL script to update the schema of the test database, and he accidentally ran it against production. So he ran this script against prod, which brought prod down. So it took about 10 seconds to get a production outage. It took us about 10 minutes to work out how to fix this and to give him a new SQL script to say, can you run this and it'll fix it. But then it took us 6 hours to get all of the sign-offs necessary to make a change to production, right? The reason is the policy at the time was that for a production deployment or production change to happen, every department that could potentially be impacted by this change needs their manager to sign off on it. One of them was out at lunch, another guy wasn't there that day. 6 hours of process just to undo a change that occurred. Now, that's not because, it was because somebody made a mistake, sure, but that process shouldn't need to take 6 hours. So you really need to optimize these kind of processes. The best way I've seen it done as well is a lot of Octopus customers used to just have the deploy button like on an iPad, and they would hand it to their manager and say, "Are we ready to go?" And the manager would go, "Oh, sure." Press the button and it's in production, which is really good if he doesn't know what the button does. And you're at the pub and it's Friday afternoon, which happens. So optimize those processes that require humans. Really work at getting those as quick as possible. The next one with the deployment process is really the idea that production is special and you can't do your deployment to your test environments the same as you do your deployment to production. In other words, yes, you can continuously deploy to test and maybe we'll do automatic deployments to staging and stuff like that, but production, that's different. We all need to come in on a Saturday every 6 months and work for 48 hours straight to get stuff working. Production should just be another environment as much as possible. This is why we have staging environments that are supposed to look exactly like production, so that when we run the tests, we know that it looks the same. It's probably going to work in production as well. Why are we not applying that to the deployment process? We have this automated process to put it in a test environment and to put it in a staging environment, but then when we deploy to production, it's the first time we have ever done that with these binaries. And that's really scary. The first time you ever test something should not be when you put it in production, right? So as much as possible, your production environment should be the same as all the others. Deploying to it should not be any harder. The key to this is making sure that you have the same process for all of your environments. Now again, tools like Octopus and a lot of the other tools make it really hard to not do this. So you have one deployment process in Octopus, and you have to run through that deployment process in all of your environments. It's hard to make a different process for different environments. So you want to make sure that not only have you tested those bits, because we only build once and we deploy many times, we've tested the bits, but we've also tested putting them on a machine. So when we do it in production, we are pretty confident that that is going to work. The next deployment thing that I keep seeing is the idea of kind of patch-based deployments. In other words, every release is a collection of differences between the last release and the current one. Changed files, here's 4 SQL scripts that we need to run over the database in production to bring it up to speed to the latest one. Now this makes for relatively difficult to reproduce deployment processes. There's so many things that can go wrong here. For one thing, all of your test environments need to be exactly the same as production now. So if you're running scripts, the schema needs to be exactly what production looks like. So iterating really quickly is quite difficult. As well as that, if something happens to production, then how do you deploy the whole thing again? Like production's gone now. How do I put it back, right? It's exploded and all I have is the changes from the last one. So the idea of patch-based deployments makes it really hard to get this repeatable process going. The solution to this really is to deploy everything every time. Now, that's often not practical. I know SSW, which is a consulting company I used to work for, their website, they kind of had a policy of never deleting any content from their website ever, for various reasons. I don't know what they are. So that meant the content of their website was about a gig. Now, if you try to push a gig to a US VM and an Australian VM every single time you want to make a change to a page, that's going to be really, really slow. But tooling can help you do this. So Octopus had a feature called delta compression, which basically means if you have 2 1 gigabyte packages, but they only differ by a tiny amount, as long as that target machine had the previous version, you just send that tiny amount and we'll rebuild it on the other side. So the tooling can optimize this. The important thing though is that you could do that same deployment to a fresh machine or to a machine that had the last version on it as well. in the practice of like database upgrades and things like that, that means using tooling like was it ReadyRoll is one of the ones. There's things like DBup for migration-based ones. Entity Framework Migrations is also good for that. Sorry, excuse me. Or other tooling that looks at the schema, works out what needs to change, and makes that change. You can apply that to an empty database, but you can equally apply it to a database which is one version behind. So making the tooling help for you so you're not actually deploying everything every single time. But you can. Right, so the release ones. Number one problem is that there's a human involved in that release process. You want to automate your deployments and optimize anything you can't automate. Don't treat production as a special environment. It should just be another environment, right? Something else you can deploy to. The other advantage for not using patch-based deployments as well is that if you want to just try something, you've written some changes and you want to just give it a go on a server, spin up a new machine, deploy to that machine because you've got the whole deployment process. Deploy to that machine, test it out, tear it down, you're done. Really good for load testing as well. You can spin something up and then just hammer it and then tear it down when you're done. So avoid these patch-based deployments too. All right, so we've gone through this develop, build, test, and release process, and a few things on each of those that can cause problems and make DevOps not work. I would just want to talk about one other thing briefly, which is actually implementing these changes, or implementing DevOps, or doing DevOps. The idea of the talk was really just that, people are saying, well, we tried to do DevOps, it didn't really work for us. A lot of the time, that's because they went and tried to do it all in one hit. In other words, they did their DevOps implementation in one go. Everybody stop writing code now, and we're going to do DevOps for a month, and then we can start writing features again. We learned like a while ago, back when Agile became a thing, that big bang like implementations of anything doesn't work. So why would we do it when we're applying these new principles and these new ideas to the way we work? We shouldn't. We should really identify like one problem at a time. What is the hardest thing right now that we have? Implement a fix for that. Automate a certain part of the problem, and then move on to the next one. So iterate, continuously look at whether stuff is working for you, and if it's not, fix it and then move on to the next thing. The important thing here though is that you need to expect to fail pretty regularly, right? You can't just implement DevOps and then that silver bullet now means that you never have to worry about how stuff works anymore. That just is not practical, right? You need to expect to fail. There's actually a really good report that comes out every year done by an organization called DORA, which is DevOps, I'm gonna get this wrong, DevOps Research and Analysis Group, run by a woman named Nicole Forsgren, as well as Jez Humble, who you may know wrote the Continuous Delivery book, and another guy whose name has just escaped me who wrote the Phoenix Project. Does anybody remember? Gene Kim, that was the one. Thank you. Gene Kim, they put out this report on the state of DevOps in different organizations. And basically they classify all the different organizations. They interview about 27,000 organizations, and they classify them in terms of how mature their DevOps process is. Usually based on things like how often they deploy, or how quickly they can deploy, their cycle time, things like that, but various other metrics. And they classify them into low, medium, and high performers. What they actually found in the 2016 State of DevOps report was that as you move from a low performer to a high performer, the medium performers actually have more change failures. So changes they introduce fail more often than high performers and even low performers, which basically means as you're starting to do DevOps better, it's going to get worse before it gets better. So you need to expect to fail. Now, the 2017 State of DevOps report actually came out about a week ago, I think. The reason I'm using the 2016 State of DevOps report is because it paints this picture. The 2017 one actually does this. So, but the point is, it's not always that easy to get this stuff working properly. You need to expect failure. I think the reason for this is probably just that our understanding of how to do things more effectively is better now, and the tooling probably stops us from making the mistakes that people used to make. So expect to fail, but it's not as bad a bad a story as it has been in the past. All right, let's just quickly jump back to our DevOps pipeline. We kind of talked about all of these sections in differing amounts, particularly the ones at the bottom that developers have a lot of control over. And there's a lot of different areas where things can go wrong and make you feel like DevOps just isn't working for us. Right from the feedback loop that we have, all the way through development, build, testing, and the release cycle as well. And even the implementation of it. The companies that say, right, we're going to do DevOps today, let's do the whole thing, and then it just doesn't work. Often it doesn't work, and you feel like it's not going to work in this organization, you're just going to abandon it and go back to the way that things were, right? So there's all of these different things that I would encourage you to look out for. And hopefully if you can make some of these changes and notice these things happening in your organization, you can start fixing the problems before they become too much of an issue and start doing DevOps a little bit better. And that is all I had. Thank you very much. Now, I think we have about 5 minutes if there are questions. Is that right? Maybe? Kind of. Make sure, by the way, if you're on your way out, make sure you do the feedback. It's really, really valuable, not just for the speakers, but for the organisers. If you're confused, just grab a green one, put it in. Instead of a red, you could just grab a stack of greens and put them in as well. Anyway, are there any questions? Yeah.
What is your opinion about differentiated CI builds versus production builds? I know it's possible to create like lighter, different CI solutions to get higher throughput, but then you're not building.
So the question, I'll paraphrase, I think, is what's my opinion on differentiated CI builds from the production builds? I don't have a problem with that at all. I think your CI build should really just be a first pass. Does everything compile? Do our unit tests run? That one should be fast, especially if you have a lot of developers developing, like writing code against it. As long as, if you introduce a compile error or something that a merge is going to break, you need to know about that as early as possible. If your CI build is going to take 4 hours, it's not really going to let you know as early as possible. So CI build that does really, really fast, basic ones with just running some unit tests, and then a separate build that you do to create a release candidate, I don't have a problem with that at all. As long as your release candidate build is going to pick up problems as well, right? If your CI build is just kind of your first pass, then you have a separate build to do a production-ready release. In fact, even having one in the middle that does like a nightly release isn't a bad idea either, that does some more work. I don't have a problem with that at all. I think it's a good idea. Yeah. Any other questions? The difficulty with this room is that there's 2 lights here, and so I can't see anything, which is kind of good because I'm just assuming that it's completely packed. Any other questions before we go? Yep, I'll go here first. So how do you sell the business on implementing these principles? I actually did a talk on that about a week ago called something like Doing DevOps as a Politically Powerless Developer. There's a lot of different ways you can do it. I think number one would be trying to make it very clear to the management that they are the bottleneck. So the CI tools and things like that, you can probably install them on your local machine. It still does a CI build. You can still notice things are ready to go. You can put Octopus on your local machine. It's not ideal, obviously, but if you can put yourself in a scenario where your manager says, hey, I want to make this change, you write the code in like 20 minutes or an hour or something like that, and then have it running in a test environment and say, hey, try this URL, does it work? And the manager goes, yes, great, that's good. How long until we can put that in production? And you're like, well, based on our current process, it's 6 weeks. It's going to become pretty clear to management that they are the bottleneck, not the developers, all right? I think it's just a matter of pushing this stuff and just keep churning away at it until they notice that that's the case. The other thing is the change in organizations really often comes from a analysis and then an acknowledgement that something's wrong and then some adjustment. So this like analysis and acknowledgement adjustment phase. You can do a lot about the analysis stuff. If you can measure the mean time to push something out and say to your manager, here's how long it took to put a production build in production, And most of that was waiting for sign-off, waiting for the test team, waiting for all of this stuff. There are better ways to do this. Can we talk about that, I think? But it is a hard problem. Like, that's the people problem, which IT people are not generally that good at, I think. But yeah, make them feel like they're the bottleneck, and then give them data to prove that this is not working very well, I think are the two I would recommend. And there was a question there? That was the exact question? Cool. Would you like me to answer it again? No? Okay. Was there somebody up there? Nope. Cool. I will be hanging around here after this if you want to have a chat a bit more privately as well, but if that's everything, thank you very much.